So, today's lesson is going to be how to draw a graph of general absolute value function. The idea is, and this is something that you should have figured out for yourself, that no matter which A, B, C, and D you're given, every time you're going to have as a graph the V, differently positioned, differently shaped, but it is going to be V, and it is either going to be like upwards or downwards, so to say. So, depending on a certain coefficient. Not gonna go into that because this is something that you have in your homework. Now, today's lesson is once you figure out what is going on with the coefficients, how can we draw the graph quickly? Now, always in mathematics, if nothing works, table is the method to go to. But I'm going to show you the table method, and I'm going to show you the second method. I'm not going to name it yet because it's a little bit specific, and then in the end we can together maybe give it the second method its name. So let's start with the example 2. I'm continuing this basically from the last time. So example 2 is going to be, let's start with a simpler function. F of x equals to absolute value of 2x minus 1. Okay, let's start with this. Let's just start with this. Now you already should know how 2 and minus 1, or 1 actually, and this is something that maybe some of you have issues in homework, is because if c is positive number, this means in front of it is a minus. If c is a negative number, this means that in front of it is going to be plus. And this is something extra in mathematics, and this is something that you have to get used to specifically for the functions. And how we go through, we're going to talk about it. So let's just, for the exercise, write down coefficients. So b is 2 and c is 1. Okay, c is 1. Minus, so c is positive. This is the idea. Because each time we are subtracting with c. This is the idea. Okay, so how are we going to draw it? The first thing that you have to notice about all of this is that inside of the absolute value, you are basically given a linear function. So, let's pretend at the beginning that we don't apply the absolute value. Let's not apply it. Let's just go through it as 2x minus 1. Okay? Now, this means we can immediately go and draw 2x minus 1. We can immediately go and draw that. So let's do it. I'm gonna go use the big... I've told you I'm going to use the table method. Let's go back to the table method. I apologize. Let's go back to the table method, then I'm going to show you the second one. It's going to be simple enough. Okay. Now, the table method first. Let's go with the table method. Okay. This means we are using x's and y's. Let's use it. Let's write it down in columns so that we know. And I'm going to encourage you to do the same thing that we did in example 1. Pick 5 values for the x. Now, how to pick these values? This is an important part. Now, the thing you want to think about is that inside of the absolute value, you want to have positive, negative, and neutral values. This means that 2x minus 1, now I can use this coloring. It's good for me. I wanted 2x minus 1 be equal to 0, 2x minus 1 is greater than 0, and 2x minus 1 is lesser than 0. I want these situations. Now, how to figure it out, which numbers are then the best for us, for the table? Don't pick any, because there is a certain chance that you can then lose some situations and get some only positive values. Now, let's go with equality just. Let's go with just equals. And you would get that x is equal to 1 over 2. So if x is equal to 1 over 2, this means that then we have the neutral value. Now the neutral value in absolute value we used in the middle last time. I'm going to show you that. We used it here. Here is the neutral value. So we use 2 more negative and 2 more to get a positive. So I'm going to write 1/2 in the middle. 1 over 2. I'm going to have 2 more values for minus and 2 more values for the plus. Now, what this means for us, if you pick a value for x that is less than 1 over 2, if you pick it with it's less than 1 over 2, for example, you pick 0. Let's just pick 0 for the x. This means 0 minus 1. 0 minus 1 is minus 1. It is less than 0. Good one. So let's pick 0. And then let's go with minus 1. Okay, let's go with minus 1. So after that neutral value, so we go basically with the neutral level, neutral value, sorry, and then we go in the minus side, and then we go with the plus side. So plus side, if I pick, for example, 1, 2 times 1 is 2, minus 1 is altogether 1, which is greater. Okay, I have a plus value, so let's go with 1 and 2. So if you see this, these are not the same values that we picked last time. These are not the same values that we picked last time for the table. And this is how you pick the values for the table itself, okay? I'm going to go through this method once again in another example so you can see and pick it for yourself. So now let's calculate all the y's or f of x's. So this is basically f of x. And we can calculate it. So for minus 1, 2 times minus 1 is minus 2, minus 1 is minus 3 altogether. Absolute value of minus 3 is 3. 0, 2 times 0 is 0, minus 1 is minus 1, absolute value of minus 1 is 1. 1 over 2, 2 times 1 over 2 is 1, minus 1 is 0, absolute value of 0 is 0. 2 times 1 is 2, minus 1 is 1, absolute value of 1 is 1, and 2 times 2 is 4, minus 1 is 3, absolute value of 3 is 3. And this is how you can also write all of this down if you want, but I've talked about it here, okay? I've talked about it here and go and how we can do it. We got a table. We have everything that we need to draw the graph of absolute value, and I'm certain that we have positive values, negative values, and 0 inside of the absolute value. This is the idea. Inside of the absolute value, if we get this, then we can apply it. We have picked correct x's. We haven't picked it randomly. We actually decided which x's we are going to use, but then we can see and apply it for the table. So x and y. Let me go with 0, 1, and 1, 2, 3, 4. Should be more to the right. I apologize. This is just a sketch for me. In your notebooks, you can go more neatly. So this is going to be 2, this is going to be 3, this is going to be minus 1, minus 2, and minus 3. This is going to be 2 and 3. Okay, I apologize. This is nothing. Sorry. So let's do the points. Now I'm not going to name them. I told you I don't have to name them, and you don't have to name them. It's just to be more precise. So let's start with the point minus 1, 3. Minus 1, 3 is here. This is the first point. 0 and 1. 0, 1. 1 over 2. 1 over 2 is going to be here, and 0. This is the 1 over 2. This is the third point. Then we have 1, 1. And 2, 3, 2, and 3. And what we should have gotten in the end is the V that looks like this. Here you go. When you draw, this is something that I haven't talked about in the last video, and that is when you draw the graph of absolute value, make sure to make it that it continues on. It continues on, not just from 3 to 3, so to say, okay? It continues on. As long as you have the coordinate system, so long should be those rays. And here we go. This is the first table method. Let's go with the second method. Let's go with the second method now. And this is going back to the idea of linear functions. Now, what does this method do? I've lost a coloring. Doesn't matter. How does this method work? Well, you're given f of x is absolute value of 2x minus 1. This means you can use 2x minus 1 as linear function, which then basically you can draw it. You can draw 2x minus 1. Okay? So let's draw it. Let's draw it. I should probably go. So I'm going to write here steps. So okay, let's draw 2x minus 1. Let's draw that. And this is basically going to be equal to y, just so that we know it's a line. And it is connected with absolute value function, but it is not itself absolute value function. Let me go here. 1, 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, 1, 2, 3, and so on. Okay. I have tried to be as neat as possible. Now, how do we draw this? Let me write down y equals to 2x minus 1. For the linear function, let's go through it once again. 2 is with the x, which means it is the slope. While minus 1 is y-intercept. Oh, minus 1. Here we go. We got the first point. Here is the y-intercept. Okay, let's continue on. Let's continue on with 2. What this means is that we have 2 over 1, which means that we are going 1 to the right and 2 upwards. So 1 to the right, here we go, 1 to the right and 2 upwards, 1 and 2. Okay, so this is the slope-intercept method, basically at this point. And this is the line. This is the line. I'm going to write this down. This is 2x minus 1. So basically, I have used only the thing inside of the absolute value. Okay? So this is the first step. Now, one thing that you should already notice is that here it will intercept the x-axis in 1 over 2. And comparing it to the table method, whole right part is actually already done. It's actually already done. Now there is one thing that so we have drawn this. Now there is something specific with the absolute value. What does the absolute value do to the negative values? It will transform them into their positive opposites. What does this mean for us? In this here case, let's look at the number minus 1. It's already here, so I can use it. Minus 1, when you apply the absolute value. So when you apply the absolute value to that, basically now I'm applying it, okay? I'm doing that extra work now, which was missing still. I didn't use the absolute value itself. Now I'm going to use it. So minus 1 will become 1. So the number that is here, for example, this is minus 2. But I'm looking on the y-axis now. I don't care about the x-axis. Minus 2 is going to become 2. And so on and so on. Dum, 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 dum. And what happens is, the whole part of the line that is beneath the x-axis will be transformed into its positive, so to say, counterpart. Now this is just a sketch, it should have gone through one, but yeah, I've missed it. And this is what absolute value does. Everything that is negative, absolute value transforms into the positive. And now you're done. This is the second method. So first draw y is equal to 2x minus 1. Then apply absolute value. Okay? First we draw, then we apply absolute value. How do we apply it? We apply it like this. And this is the whole thing. Okay? Now there is going to be this is now specific in this here case. I would like you to try for yourself. Yeah. But you will have some extra time for this, okay? Since I wasn't able to give you the last week's lessons. I've given them basically to today on Tuesday. I'm going to give you for this homework more time. So let's say we are doing it through this week. If you don't have time today, do it tomorrow, do it so on. But if you have time, do it immediately so that you have less things in the future. So try for yourself drawing f of x equals to 3x plus 2. This would be another one to draw. So, to try out for yourself. Okay, let's continue on. I would like to show you one more example using the table method and the drawing with a line. So this second one can be the line method, because at the moment we have a line, and after the first step you have the line, and then applying the second step or absolute value where it transforms everything that is beneath the x-axis, transforms into the positive, then we can call it the line method. Okay, so example 3. And this is almost the big daddy of the absolute value functions. F of x is equal to minus absolute value of x plus 1. I said almost, it's not yet. And then plus 2. Let's go with the table method. Now, first thing is that you have to notice with the example, sorry, this is example 3. I apologize. So with the example 3, difference between example 3 and example 2, let me show you. I have here both of them. Well, now we have minus in front of the absolute value. This is the first difference. And then the second difference is that I'm adding 2 to the whole absolute value. And then we're going to see what happens then. Now, you already should know what does this all mean. Now, let's try, for the exercise and practice, just write down the coefficients. A is actually minus 1. B is 1. You have nothing in front of x. C is minus 1 because you have plus and you want to subtract. And D is 2. So these are the coefficients. Okay, let's use the table method again. Table method says that we have x's and y's. Y's are actually values of f of x. So we have to again pick certain specific x's. I don't want to go all the way random. I want to have positive values for the absolute value, or inside of the absolute value, sorry. I want to have neutral values and I want to have negative values. So we have three situations that we have to pick up. 2 positive, 1 neutral, and 2 negative. So let's simplify it a little bit. I'm still talking about only what's inside of the absolute value. I'm still thinking about only that. So x plus 1 equals to 0, which means x is equal to minus 1. So when is x equal to minus 1, we're going to get inside of the absolute value is 0. This is the idea. So the middle the middle value that we're going to pick is going to be minus 1. Okay, we've picked minus 1. And you can already down. Okay, I cannot calculate y yet. Sorry. Now, if I pick a value that is less than minus 1, for example, minus 2, minus 2 plus 1 is minus 1, which is less than 0. So I can pick minus 2, and let's go with minus 3. Why not? Let's go with then in another direction too. So if I pick 0 and 1, so with 0, 0 plus 1 is 1, which is positive, 1 plus 1 is 2, which is positive, so I have 2 negative, neutral, and 2 positive values. Now, if you're not certain, you can also write these down. These are 2 negative, this is the neutral, and these are positive. So this is minus, this is neutral, and this is plus. Okay, this is the idea. But the result of inside of the absolute value, we have these situations. Okay, now we have to calculate y values. So for x is equal to minus 3, I have to write it down. So the y is going to be minus absolute value of minus 3 plus 1 plus 2 is y is equal to minus 3 plus 1 is minus 2, which is then 2 plus 2, and it is equal to 0. So result is 0 altogether. Now this is all together, okay? This is all together. For x is equal to minus 2, y equals to minus absolute value of minus 2 plus 1 plus 2. This is minus in front. Minus 2 plus 1 is minus 1. So absolute value is 1 plus 2, and it is plus 1. Okay. X is equal to minus 1. This means that y equals 2. Minus 1 is 0. It is 2. X equals to 0. Then y is going to be minus, so let's write down minus 0 plus 0 plus 1 plus 2. I apologize, I lost myself for a second there. Minus 1 plus 2, and it is 1. So 1, and then with x is equal to 1, when you go through the same method again, we're going to get 0 in the end. Because you have minus 2 plus 2, it is 0. Okay, so we have the table. We can draw it. Let's go and draw it. Okay, let's now, personally, let me talk about it for a second before I continue. Personally, those methods, first and second, are equally good. There is a little bit more work with the first method, of course, but every time you're going to get the v using this method. Picking the values for the x's is always what's going on inside of the absolute value. Inside of the absolute value, as a result, you're going to have positive, 0, and negative numbers. This is how we got them. Usually we go through the neutral or getting the 0, and then we are certain that lesser or greater numbers are going to result in a positive and negative solutions inside of the absolute value. So when you apply the absolute value, you're going to get everything that you have to. But it is also good, and I really like it, and I do use it even today sometimes. So let's draw now finally this 0, 1, 1, 2, 2, 3, 3, minus 1, minus 2, minus 3. Here we go. So first value is minus 3, 0. Minus 3, 0. This means this is this here point. Minus 2, 1. Minus 2, 1. Here is the second point. Let's go with the third. Minus 1 and 2. Minus 1 and 2. Then we have 0, 1. 0, 1. And then we have 1, 0. 1, 0. There you go. And this is the graph of this absolute value function. There you go. You have drawn it. Now let me show you the second method. How to apply it. In the second method, Now, you should know why is it turned downwards, this V. You should know why. Is there something with a minus? But this is up to you. Okay, let's go with the second method. Let's draw a line at the beginning. Okay, let's draw the line. Y equals to x plus 1. Okay, so we are drawing x plus 1 at the beginning. So this is basically everything that is inside of the absolute value. So what does this mean? I'm going to draw the big here coordinate system. I need to show it a little bit larger. 1, 1, 0, 1, 2, 3, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Oh, I messed it up in the end. I apologize. Okay, x plus 1. X-intercept is, let me use different colors. So let me start with this color, okay? X plus 1. So y-intercept is 1, the slope is 1, which means 1 to the right and 1 upwards. And this is the y equals to x plus 1. We have it. Let's apply the absolute value now. Let's apply the absolute value. What is the absolute value? So the second step is absolute value. 2y equals to x plus 1. Okay? Which means that we're going to transform it. Everything that is beneath is going to go above. And this is going to be the result. Okay, so this is the absolute value. This is the absolute value. Let's continue on. Let's do the minus. What does the minus do? Now this is specific to the minus. Everything that is positive becomes negative, and everything that is negative becomes positive. Everything that is 0 doesn't change anything. So let me use the light green color. So minus in front of the absolute value. So this is the third step. I'm drawing it in colors. So minus in front of it means that everything that is above goes beneath. Everything that is positive becomes negative. So this whole thing becomes this. Okay? This is now minus absolute value. Okay? This is now the minus absolute value. And the last thing is the plus 2. Now, what you should have learned by now is using the GeoGebra that the number on the side, if it's positive, translates the whole thing by 2 upwards, or if it was negative, by that amount downwards. What this means for us? Now we have to pick certain values. Okay, if it transforms it plus 2 upwards, this means that this here point is going to be translated here. So this is by 2, so plus 2. Well, this means for any other point. For example, this here point is going to be transformed. So this here point is going to be transformed here. Here. And so on and so on. Okay? And what we're going to get in the end, I apologize, this is only a sketch. And this is graph of f in the end. So these are 4 steps that we have to do. Is it simpler? Maybe. But it looks a bit crowded in the end. And you have to point out that this is the resulting function. Graph of the function. There you go. And this is how you draw absolute value functions. The graph of the absolute value functions. These are the steps. Go with linear, apply absolute value to that linear. So applying absolute value to the graph means everything that is beneath goes above x-axis. Applying a minus if there is a minus. If there is not a minus, you don't care about it. Okay, you got rid of it. Applying the minus, which means that everything that is above becomes everything that is beneath the x-axis, and then add 2, which means translate everything to upwards. If it was -2, everything will just translate it by 2 downwards. And there you go. These are the two methods you can use for your homework. Last task that I would like you to try for yourself, going to be similar to this, just to try it out, is going to be f of x equals to minus 1 over 2x plus 1 and minus 3. There you go. Just so you test it out for yourself, okay? Watch out, you will need extra space beneath x-axis. Now, for this homework, whoever wants, you can send it to me the results. I'm going to put it in Ednevnik that you have done it. So let's see some of your own incentive concerning this. And you can send me at any time. I might not respond immediately, but you can send me. Thank you very much for watching this video, bearing up with me. Hope everything you understood. If you didn't understand something, you know where to find me. And see you guys in the next video.